Okay, this is my favorite lecture in this course because there are so many blog posts and videos about repositories, and many of them conflict with each other, which made me confused about the repository pattern for a long time. So, in this lecture, I'm going to explain clearly what repository is and what it is not, why and if we need it, and address some of the misconceptions about repositories. So, what is the repository pattern? I'm going to start with a definition from Martin Fowler's book, Patterns of Enterprise Application Architecture. Repository mediates between the domain and data mapping layers, acting like an in-memory collection of domain objects. I've highlighted in-memory collection in this phrase because that's the key here. So what are the benefits of the repository pattern? The first one, again based on Martin Fowler's book, is that it minimizes duplicate query logic. So imagine in a few different places in our application, we need to get the first 5 top-selling courses in a given category. Without the repository pattern, we'll end up duplicating this query logic over and over in different places. In situations like this, we can encapsulate this logic in a repository and simply call a method like getTopSellingCourses, which takes 2 parameters, the category and the number of courses to return. So this is one benefit of the pattern. Another benefit of the repository pattern is that it decouples your application from persistence frameworks, in this case Entity Framework. So in the future, if you decide to switch to a different persistence framework, you can do so with minimal impact on the rest of your application. Now, the first argument that comes here is that some developers say, but who would change the persistence framework of an application? Well, let me tell you something. The fact that this does not happen very often is not because it's not desirable. It's because most of the time, application architectures are so tangled and tightly coupled to Entity Framework that it doesn't give us the freedom to change it. A while ago, I read somewhere on a blog that on average every 2 years we get a new persistence framework, and I think that's very true. First we had ADO.NET, so we used SQL connection and SQL command to access the database. Then Link to SQL came along, but it didn't prove to be successful. Next, Entity Framework version 1 arrived, which had so many issues. Nearly at the same time, NHibernate got popular. Then after 4 versions, Entity Framework reached a stage that it was reasonable to be used in production. But still at this point, it had a heavy object model that was not testable. Then they introduced a new model, dbContext. Now they are working on version 7, which is a complete rewrite, and there are some breaking changes. Not to mention that along these lines, we have had other persistence frameworks like Dapr, ORM Lite, Petapocos, and so on. So our persistent frameworks are constantly changing and evolving. And if you want to have the freedom to explore a different persistence framework with minimal impact in your application, that's when you should use the repository pattern. Now, there is also another benefit with the repository pattern that some claim, that it makes it easier to unit test your application. But that's partially true. And that's if you're using an older version of Entity Framework with object context and object set. The new dbContext and dbSet objects have interfaces that you can mock to unit test your applications. So you don't necessarily need the repository pattern to unit test your application. Now, the theory behind what is the repository in practice. In a nutshell, this is what your repositories should look like. They should act like a collection of objects in memory. So we have methods to add or remove an object, get an object by ID, get all objects, or find them using a predicate. Note that here we do not have a method called update. Because with collections in memory, if we want to update an object, we simply get it from the collection and change it. We don't tell the collection to update an object. And that's one of the areas that a lot of developers get wrong. A repository should not have the semantics of your database. It should be like a collection of objects in memory and shouldn't have methods like update and save. Now with this, the first question that pops into a lot of people's head, including myself a long time ago, is if the repository acts as a collection of objects in memory, how are we going to save these objects and changes to them to the database? That's when the unit of work pattern comes in the picture. A unit of work maintains a list of objects affected by a business transaction and coordinates the writing out of changes. And this is where things get interesting. Some developers argue that both the repository and unit of work patterns are already implemented in Entity Framework, and there is no need to recreate them, as this would lead to unnecessary complexity. Let's see if this argument is valid. So the argument says that dbset has a collection-like interface. So it has methods like add, remove, find, where, and as you see, it doesn't have methods like update and save. So perfect. Also, the argument claims that the db context acts as the unit of work. It keeps track of changes in the objects and coordinates the writing out of changes. As you see here, a db context has references to one or more db sets, and the save method is actually implemented here. So again, it makes sense because, as I explained, the save method should not be in the repository. Plus, chances are, in a business transaction, we may work with more than one repository. So that's the reason the save method should be in the unit of work. So it will coordinate persisting changes across multiple repositories in one transaction. So, on the surface, yes, Entity Framework DB sets and DB contexts indeed look like repositories and unit of work. But there is a hidden problem here with the implementation of these patterns in Entity Framework. Let's review the benefits of the repository pattern again and see if our DB sets satisfy the definition of repositories. So, a repository minimizes duplicate query logic, and I showed you an example of this before. Now, the problem with dbset and link extension methods implemented on them is that they return iQueryable. And this means if you want to get top selling courses, you will end up repeating these few lines in a few different places in your application. In fact, in one of the projects I worked on recently, this was exactly the case. So DB context was everywhere, and we had long, fat queries repeated over and over. What you see here is actually a very simple example. I've seen worse. So the implementation of dbset does not really help with minimizing duplicate query logic. Yes, you can argue that we can use extension methods to encapsulate this logic into a method in a dbset. And believe me, we had exactly this scenario in that project. In my opinion, this solution treats the symptoms, not the actual problem. Because even if you use extension methods, all the existing link extension methods on dbset still return iQueryable. And next time a developer joining your team is going to use them to write new queries. So in this case, ideally, we want a repository that has a method like get top selling courses. And all this querying logic is encapsulated there. The DB context should be a private field in the repository and not exposed to the outside. It's the implementation detail. Now, the second benefit of repository pattern is that it decouples your application from persistence frameworks. When you're using DB context and DB sets directly in your application is tightly coupled to Entity Framework. If you want to upgrade to a newer version of Entity Framework with a different model, or switch to a different ORM, you need to modify your application code directly. However, if all this is behind a repository and your application code relies on the repository to return the right data, it doesn't matter what is inside the repository. Today, you can use Entity Framework in a repository. Tomorrow, you may decide for optimization reasons to replace it with store procedures. Your application code will not be affected in any way. It simply asks the repository to get the data, and repository does its job. It doesn't matter what's inside the repository, how it's done. Are we using store procedures? Are we using Entity Framework? Are we using object context or DB context or a different ORM? It doesn't matter. So with all these, in my opinion, while DB sets and DB context in Entity Framework do look like the implementation of the repository and unit of work, they don't really bring the architectural benefits that we can get from these patterns. If you have not read about clean architecture, I highly recommend you to look it up. Uncle Bob or Robert C. Martin has a beautiful post on the topic, and my favorite line in that post is, "The architecture should be independent of frameworks." This allows you to use such frameworks as tools rather than having to cram your system into their limited constraints. So that's why using patterns like the repository pattern help you decouple from frameworks such as Entity Framework. Now, the theory aside, I want you to think like an engineer. Be pragmatic, keep it simple. My favorite quote is that simplicity is the ultimate sophistication. Just adhering to clean architecture principles and using all sorts of patterns doesn't necessarily make you a better coder. Neither does it improve the quality of your software. Not every application needs sophisticated architecture like this. A lot of times you might be building simple or proof of concept applications for a limited audience. Please don't do over engineering. A while ago, I worked for 5 months on an application where its requirements were rapidly changing. And there, I didn't use any of the stuff I talked about in this lecture. I had no repositories, no clean architecture, no unit testing, not even dependency injection. Because we were not sure if the application would even make it to the production for financial and political reasons. And guess what? The application never made it to the production. So if I spent a lot of time adhering to all these architectural best practices, I had just wasted my time. It wouldn't bring any values. Some developers simply use patterns without really understanding the problem, and this way they feel good about themselves. My pragmatic suggestion to you is use patterns only when you need to. Don't use them as deodorants to make smelly code smell good. Now in the next lecture, I will show you how to implement the repository and unit of work patterns with Entity Framework. I hope you enjoyed this lecture and thank you for watching. Alright, now let's see how we can implement the repository pattern with Entity Framework. First, I'm going to show you a diagram of the interfaces and classes, and then we'll explore the code. So to start with, we need a repository interface. This interface is like the interface for a collection of objects in memory. So it has methods like add, remove, get, and find. Again, here we're not going to have update or save. Next, we're going to implement this interface in a class called repository. Inside this repository, we're going to have a DB context, a generic DB context. So what you see here is completely generic. It's got nothing to do with our application. We can reuse this interface and the concrete implementation of it in any applications. In context of our application, Pluto, for each entity, we're going to have a repository. So for course entity, we're going to have an interface called iCourseRepository. In this interface, we're going to define any operations specific to courses that are not in our generic repository. For example, we can have a method like get top selling courses, or another method, get courses with authors, which uses eager loading to load the courses and their authors. So this is one of the key things here. Anything to do with eager loading or explicit loading is data access concern. Your application code, your business logic should not care how this is done. This is the implementation detail that should happen inside a repository. Your business logic layer, your services, simply tell the repository, give me courses and their authors. And the repository works out how it should be done. Now here, iCourseRepository just declares the contract. So we need to implement it in a class like CourseRepository. So in this diagram, CourseRepository derives from our generic repository because a lot of our data access code is similar. But it also additionally implements iCourseRepository interface. So it's going to have implementations for these two methods you see on the right side. Next, unit of work. So we need an interface like iUnitOfWork. This interface is specific to our application. So it's going to expose various repositories based on the entities we have in our application. For example, here we have two properties, courses and authors, and the types are iCourseRepository and iAuthorRepository respectively. And note that here we have a method called complete, which indicates the end of a unit of work. We could call this save, but I personally prefer to call it complete because this is completion of a unit of work. Next, we need a class to implement that. So we're going to call this unit of work. Now let's flip over to Visual Studio and see all these interfaces and their implementations in action. I'm going to take you through every interface and their implementation, but you can also download all the source code in the supplementary materials of this lecture. Let's start with iRepository. Okay, here's my iRepository interface. Note that this is a generic interface where tEntity is a class. Some developers like to have a marker interface like iEntity and decorate their domain classes like course, author, tag, cover, and so on with that interface. Then here you could say where tEntity is iEntity. But I personally don't quite like marker interfaces because it's like fooling yourself. It doesn't bring any value. Anyway, here we have three groups of methods. The first group is for finding objects, the second group is for adding objects, and the third group is for removing objects. So the first method, get, receives an ID and returns an entity with that ID. We also have getAll, which returns all objects, and find, which takes a predicate. This predicate is an expression of func. So this means we can use a lambda expression to filter objects, exactly the same way we use the where method with link. Next we have add, which adds one object to the repository, and add range, which adds a list of objects. And similarly, we have remove and remove range. So as you see, this repository interface is like a collection. It doesn't have methods like update or save. Now let's look at its implementation. So here's my generic implementation of the repository. Note that it takes a DB context in its constructor, and this is generic. It's got nothing to do with our application, so it's not Pluto context. I have declared this as protected because in derived classes like course repository or author repository, I'm going to use it. Now look at getAll. This method returns iEnumerable. It doesn't return iQueryable. And that's the key thing here. Your repositories should not return iQueryable, because this can give the wrong impression to the upper layers like services or controllers that they can use this iQueryable to build queries, which is completely against the idea of using a repository in the first place. Your repositories should encapsulate your queries so you do not repeat them. So here in getAll, I simply call toList to return an iEnumerable. Now the implementation of other methods like find, add range is pretty similar to using a normal DB context to adding objects or removing them. So nothing special here. Again, you can download the source code and study it on your own. So note that this iRepository and its implementation are completely generic. They got nothing to do with our application. Now let's take a look at the custom repository. So I'm going to show you iCourse repository. So this interface derives from our generic repository interface. So it's going to inherit all those generic operations like add range, remove, get, and so on. But it also declares two additional operations: get top selling courses and get courses with authors. Again, note that both these methods return iEnumerable. So we're going to execute the query inside the repository and return a list of objects to the client. Now let's take a look at the implementation of this interface. So this class, course repository, derives from our generic repository because we don't want to repeat all that code for adding, removing, and getting objects from the repository. So it inherits from repository of course and also implements iCourse repository. So here's the implementation of the methods in this interface. Now get top selling courses does not really have the actual implementation of getting top selling courses. All I'm doing here for simplicity is ordering courses by their full price and getting the first few most expensive courses. So this is not really top selling, but you got the idea. Now look at this method, get courses with authors. This method uses eager loading to load courses and their authors. So we start with courses, then include authors, then order by, skip, and take, This is for paging, because we have supplied a page index and a page size. So this is another technique that you can use with repositories. Some developers think they have to use iQueryable so that they can apply filtering in the upper layers like services or controllers. But your filtering for pages shouldn't happen in those layers. It's data access code and should happen inside your repositories. So the way to do that is by passing two parameters here, page index and page size. We could optionally give this a default value to make calling this method easier. Like page size is 10 by default. Now here I have declared a property for simplicity. This property is of type Pluto context. So all I am doing is casting the context that we are inheriting from the generic repository, the base of this class. We're casting that to Pluto context. Otherwise, in every method here, I had to repeat this code. Cast the context first, and then get access to the courses DB set. Now let's take a look at unit of work. So here's my iUnit of work interface. Note that it inherits from iDisposable and exposes two repositories, course repository and author repository. And note that both these are interfaces. This is for testability. So we can mock this interface and these properties in our unit tests. And here's my complete method. Let's take a look at the implementation. So this unit of work, as I said, is specific to our application. So it receives Pluto context in the constructor and store it in a private field here. And this is the interesting part. It uses the same context to initialize both repositories. So the client of unit of work will instantiate a Pluto context, and then we'll use this context across all repositories. Next, here is the implementation of the properties, courses, and authors, which were declared in our interface. The complete method simply calls the save changes on the context. And here's the implementation of the dispose method. So we simply dispose the context. Now, how can we use all these interfaces and classes all together in our application? Let me show you an example. So in a console application, we simply have this using block. And inside this block, we initialize a unit of work with a new Pluto context. Now, this is not how you do it in ASP.NET MVC or WPF applications. There, we don't really use the using block. This is just for console applications. I'll show you how to use this later in ASP.NET MVC and WPF. Okay, now let's go through 3 examples. I'm going to get a course with ID 1. So I start with unit of work. Exactly like how we start with DB context. Now here we have authors and courses. Again, similar to DB context. The difference is, instead of DB set, these properties are repositories. And these repositories, as I explained, are generic. Unlike the DB set, they know nothing about Entity Framework. So this way, we decouple our application from Entity Framework. So unit of work.courses dot get, here's the ID. That's it. Another example. I want to get all courses with their authors. So unit of work.courses. And because this is iCourse repository, here we have those additional methods that were declared in iCourse repository. So get courses with authors. First page, and the page size is, let's say, 4. So everything you learned in this course about DB context and DB set and querying applies here. The only difference is you're working with different interfaces that are not part of Entity Framework. Let's go through one more example. Earlier in the last section where I talked about removing objects, you saw that in order to remove an author and his courses, because we didn't have cascade delete, we had to remove the courses first in order to remove the author. So I want to remove an author. First, I need to get it. Unit of work dot authors dot get author with courses. So this method was declared in iAuthor repository. It's specific to our application. Author with ID 1. Now I need to delete all his courses. So unit of work dot courses dot remove range author dot courses. Now I can delete the author himself. Unit of work dot authors dot remove author. And finally, I need to complete my unit of work, so changes will be saved to the database. So unit of work dot complete. That's how you should use repository and unit of work. So again, download the source code, study it on your own, and if you have any questions, feel free to post them in the discussions area. In the next lecture, I'll show you how to structure your application. I hope you enjoyed this lecture, and thank you for watching.